What is an off-by-one loop error and how do I fix it? Imagine writing a loop that should process every item in a list, but it ends up missing the last one or trying to access something beyond the list. That's often caused by an off-by-one error. These errors happen when the loop's starting or ending condition is set incorrectly by just one unit. It might sound small, but it can cause big problems like incorrect results, crashes, or strange behavior. In programming, loops are used to repeat actions, like going through each element in an array or list. If you want to process all items, you need to set your loop boundaries carefully. For example, if you have an array with 10 elements, numbered from 0 to 9, your loop should run from 0 to 9. If you accidentally set it to go from 0 to 10, you'll try to access an element that doesn't exist, causing an error. That's a classic off-by-one mistake. This kind of error often comes from confusion about whether your loop should include the last element or stop just before it. Many programming languages use zero-based indexing, meaning counting starts at 0. So, when looping through an array of size 10, the last index is 9. If your loop condition says less than or equal to the size, you might go one step too far. A common example is the fence post problem. If you're counting fence posts needed for a certain length, you might forget that the number of posts is one more than the number of sections. That's a similar off-by-one mistake. To fix these errors, first check your loop boundaries. Decide if your loop should run from 0 up to but not including the length or from 0 to the length -1. Using less than signs instead of less than or equal to can help keep your ranges clear. Another good habit is to use half-open intervals, where the start is inclusive and the end is exclusive. For example, from 0 to less than n, this approach makes it easier to avoid off-by-one errors because it's consistent and simple. Before running your code, try manually simulating the loop with small data sets. Write down the indices it will access and see if it covers everything correctly. This quick check can catch mistakes early. Writing test cases that include empty lists, single-item lists, and very large lists can also help. These tests will show if your loop handles all cases properly. Understanding how your data structures work is important too. If you're working with arrays, strings, or other collections, know whether their indices start at 0 or 1. In languages like C, strings are null-terminated arrays, so indexing is zero-based. Finally, use debugging tools or step-through debuggers to watch your loop run. Seeing each iteration and which elements are accessed can reveal where the off-by-one mistake is happening. By following these steps, you can identify and fix off-by-one loop errors. Getting this right makes your code more reliable and prevents bugs that are often tricky to find. Mastering this simple but common mistake will make you a better programmer and help your programs run smoothly.